All right, so here we are in your Savas Realize Reader. We're going to be solving rational equations. So, of course, our essential question is how can you solve rational equations and identify extraneous solutions? We'll talk a little bit about the extraneous solutions part, but that's going to be more on our next lesson for Thursday. So let's just go ahead and get right into a problem real quick. All right, we'd like to know the solution to a rational equation. And remember, the parent function for a rational equation is just 1 over x. But aside from that, just solving this, back in Algebra 1, y'all had a tool for solving these. Ooh. And might have been called cross multiply, something like that, but it looked something like this. So first thing, I'd like to express this 2 as a fraction, just because it's nice if you're going to be cross multiplying. Now I'm going to do this the way that you would normally do it, and then I'm going to show you the new way to do it because this works for simple rational equations like this, but when they get more complicated, cross multiplying is nasty. You'll wind up with all kinds of junk everywhere. It's really hard to sort out. So I'm going to give you a method. We're going to find a common denominator, and that's going to eliminate all of that. But the way you saw these in the past was you were supposed to write cross multiply. So you're supposed to multiply 1 times 1, and that would go on one side, right? And then on the other side, you would multiply 2 times x plus 4, right? And that would go on the other side. You would distribute your 2. So 2 times x is 2x. 2 times 4 is 8. 1 times 1 is 1. And then you've just got a simple linear equation that needs to be solved at this point. So I'll subtract 8 from both sides and divide both sides by 2. And we get the answer of negative 7 halves. All right, so now I'm going to show you a different method for solving that. So I'm just going to write the original equation over here, right, expressing that 2 as a fraction, 2 over 1. And now I'm going to talk a little bit about common denominators, because the way that we're going to solve these from now on is going to be to find a common denominator. I'm not saying that this is wrong. It's right. It's good. And you can do it that way. But what I am saying is that when these things get more challenging, don't do it like that. So what if I had to add 1/4 and 1/3, totally aside from this problem? This has nothing to do with the problem. I'm talking right now about common denominators. So a little side note over here. Talking about common denominators. Maybe I'll title what we're doing over here. Right? When you're adding fractions, you can't add them unless they have a common denominator. So you got to think, hey, what is the smallest thing that is divisible by both 4 and 3? And it turns out in this case, it's just the product of 4 and 3, or 12, right? So I say, okay, the smallest thing that's divisible by both 4 and 3, I didn't need to put a 1 on top of there. Sorry about that. Jump again. So I would like that one to be 12. I want that one to be 12, right? And remember the way that we figured out what goes on top right here is, oh man, I gotta not do that if I don't have my smart board. Sorry about that. If I don't have my smart notebook. The way that we figure that out is how did we get 12? We had to multiply by 3, right? So if we go ahead and do that to the numerator, to the denominator, we'll also do it to the numerator. So 3 times 1 will give me 3. So it's just recalling a little bit of fraction work, right? In order to get to 12 in my second term, I had to multiply by 4. So I'll multiply my numerator by 4 as well. Then we're going to add those, and we get that that is 7/12. We're going to do something similar with with our rational equation over here. So we got to find a common denominator. I'm going to tell you that every single time, if you want a common denominator, you can just multiply the two denominators and it will give you your common denominator. So let's go ahead and do that. I'm going to erase this common denominator stuff over here. So I'm going to need a little space. Okay. So in this case, and I'm going to call it CD, our common denominator is going to be the product of our denominators. So x plus 4 times 1. Okay, which is just x plus 4. All right, now the trick here is if I multiply the entire equation, right, by x plus 4, both of my denominators will wind up canceling out, and I'll have a nice, easy linear equation. So let's do that. So if I multiply the x plus 4 there, I wind up with x plus 4 over x plus 4. And then I'm going to multiply it over here as well, and I wind up with, right, the equal sign's got to be there. 2, my bad. Let's put in a fraction. So that's 2 times x plus 4 divided by 1. So x plus 4 over x plus 4, this deal right here, right? That's just 1. So already does 1. And then I'll distribute the 2. So 2 times x is 2x. 2 times 4 gives me the 8. And of course, right, this denominator of 1, it's just there so that we have two fractions. But the dividing by 1 doesn't change anything. So we can just make that go away. Now we've pretty much got the same equation here. And you can see that if we were to continue solving, we would get -7/2. Now, whenever we're solving rational equations, we've got to check. Remember back in Algebra 1, you would take your original equation and you would substitute in your answer, right, to make sure that your answer was correct, right? You could check it by substituting your value in for x. And in this case, that's not really what we're doing. What we need to do with rational equations is we need to make sure that this denominator does not equal 0. And in this case, it won't, right? -7/2 plus 4 is not going to be 0. That's all we're checking for, okay? If you plug your answer that you got back in and you don't wind up dividing by 0, then it checks. And we'll come later on, we'll check one later on and we'll find that there are solutions that are extraneous because when you plug them in, you get 0. But we'll focus on that more later. I just didn't want to start doing this without showing you how to check.
Mr. Dorman? I had a question.
Cool.
How did you get like -7 on that problem? Because I didn't understand completely how you got it.
All right. That's not what I wanted to open. All right, another one. And now we're just going to do it with that common denominator method. All right, so first thing I want to know is what's my common denominator? It is going to be, and we'll write it first, my bad. It's because we don't have a denominator here, so let's give it one. I'm going to call it 5. Of course, these are going to get much more complicated later where maybe you'll have to find the common denominator where both the denominators are like maybe x minus 3 and x plus 2. So it's not too complicated now since one of the denominators is 1. because that just becomes x minus 3, right? So my method is I'm going to multiply everything by x minus 3. All right, so when I multiply that term by x minus 3, I wind up with x minus 3 over x minus 3. And when I multiply that term, I wind up with 5 times x minus 3 over 1. X minus 3 divided by x minus 3 is 1. So we'll leave that as a 1. And now we'll distribute the 5x. So we'll wind up 5, sorry. Distribute the 5. 5 times x is 5x. 5 times negative 3 is negative 15. Let's add 15 to both sides. And divide both sides by 5. And I look at this fraction, I say, hey, can that thing be simplified? And the answer is no, because 5 is only divisible by 5 and 1, and 16 is not divisible by either of those. So this is a simplified fraction. I need to also look and say, hey, if I plug this back in here, will I get 0 in my denominator? The answer is no. And so I have checked it. I'm going to just indicate that I went ahead and checked my answer, made sure that it wasn't extraneous, made sure that it didn't make me divide by 0. And that's that. Cool. All right. Well, now it's time for us to do a word problem. Okay. All right. Here we go. I don't know why it skips those things. Weird. All right, Cheyenne and Arthur. So first of all, let's talk about how we're going to set these things up. So for a work rate problem, it's just a word problem that winds up with a rational equation that we have to solve. This is the way we're going to do this. So I like to set it up with our so let's go part of job done. Sorry, these set up a little differently than they did last year. Your denominator here is always going to be your work rate number 1, and you might have a lot of them. You're going to have a work rate 2, and then you could have a bunch more of them, right? We'll usually only be working with 2 or 3. We're going to say that's equal to the rate together. Right, and that makes sense, right? You've got a work rate 1, work rate 2 work together. How much of the job do they get done is what's going to go on your numerator. Okay? How much of the job done? Yeah. I think that's a good way to look at it. Yeah. And then we'll also, this will be our amount of the work done. And this one as well. These will be fairly easy to figure out what goes in our numerator. All right. So that's kind of in words the way that we're going to set these things up. let me show you what that means when we put that into context. Okay. So, we know we're going to have, right, some denominator. Why are you not writing? Son of a monkey. Great. What? Maybe that fixed it. Beautiful. Okay. All right. So I know I'm going to wind up with some fraction plus some fraction equals some fraction that represents their total together, right? We've got two people. We've got a work rate 1, work plus work rate 2 is going to be their rate together, all right? So it says that they paint a wall in 6 hours when working together, right? So working together, their work rate together then is 6. That's what's going to go on the bottom there. And it says one wall. So how much of the work do they get done in 6 hours? All of it. They get one wall done, okay? One wall done in 6 hours. All right. So how long will it take Cheyenne to paint the wall if she were working alone? All right. So I think that means that Cheyenne's work rate is our variable, right? So we've got Cheyenne's work rate. How much of the wall does Cheyenne get done? Well, she can actually do 2 in the same amount of time that it takes Arthur to do 1. All right, so now we've set up our equation. Let's go ahead and use a common denominator to solve it. What would our common denominator be? Now, I could multiply all of these in order to get my common denominator. Or I could realize that and it wouldn't be wrong to say, so we could say our common denominator was 6x squared, right? Because that's 6 times x times x. And you would get the right answer. You'd have to do a little extra work. There's actually a smaller thing that is divisible by both 6x and x, right? And that's just 6x, right? Isn't 6x divisible by x, right? It's 6. And 6x is divisible by 6. The answer is x. So the smallest thing that is divisible by both x, and 6 is 6x. I'm going to multiply both sides by 6x. Or everything by 6x. So we'll wind up with 2 times 6x over x plus 1 times 6x over x plus 6x over 6. We'll just simplify this thing and solve. So we wind up with 12x over x when we multiply, just taking it step by step here. And in this case, the 6's are going to cancel, right? So those are going to, 6 over 6 is 1. So there's that. Those are going to cancel as well. We'll wind up with 12 plus, those will cancel, 6 equals x. So then x is 18. So it would take Cheyenne 18 hours if she was working alone. And I'll make sure to write that. 18 hours alone. Okay. Cool. I think we should do another one of those, yeah? All right, then. Let's do it. Okay. All right, so then again, the setup, right? We have a pipe, it's gonna be some fraction. We've got another pipe, and then we've got their work together. They're filling a pool, right? They're filling, wait a second, yeah, a pool. So they get one pool done in 12 hours when they're working together. Yeah, so we got to work rate together. One pipe flows 3 times as fast as the other pipe. Okay, so we'd like to know what the rate is. So we don't know either rate, right? We don't know the rate of the slower one. We don't know the rate of the faster one. What we do know is that the slower one does that amount of work, fills one pool at a certain rate, but the faster one can actually do 3 pools at the same rate, since it's 3 times as fast, right? And now that we've got the setup, which I think is the most challenging part, right? We can find a common denominator and solve. So the common denominator is 12x, right? That is the smallest thing that is divisible by each one of those denominators, 12x and x. So then we'll go ahead and multiply everything by 12x. All right. And I'm going to go ahead and do the actual multiplication on this one just to save a step. So 3 times 12 is 36. X over x. 12x over x. And we multiply 12x times the 1. And then 12x times the 1 in our last term gives us 12x over 12. All right, we are going to realize that these x's cancel, those x's cancel, and those 12's cancel. We wind up with a fairly simple. Wow, I wrote an equal sign there. There should not be one. My bad. Sorry about that. That should be a plus sign. Okay, plus 12 equals x. Fantastic. Let's add those guys together. So 48 is x. So what does that mean? That means that the slower pipe is going to take 48 hours. Okay, the slower pipe will take 48 hours. And there you go.